This video corresponds to activity 2.2 to the concept of scientific notation. We are going to be learning in this video how to represent certain numbers using scientific notation. So the question is, what kind of numbers do we represent using scientific notation? Basically any kind of number, but the scientific notation is really put together to represent very, very large numbers and very, very small numbers. So if you can imagine the distance from Earth to the Sun, between Earth and the Sun, this is an average of 95 million miles. Okay, or if we think about the very tiny size or opening of a very tiny virus, okay, then we have very small numbers. So scientific notation uses exponents to represent the numbers. So we usually represent numbers using what we call the standard form. Okay, a standard form. So the standard form is the form that you have been using to represent numbers, and numbers represented in a standard form are written using a decimal notation. So this is decimal notation, okay, and you are absolutely very familiar to this form. You always write in this form. Now scientific notation uses exponents. So scientific notation, numbers that are represented in scientific notation are represented in the form a times 10 to the n, right, where a is a number between 1 and 10, okay, and n is an integer. Okay, for example, a number like 9 10 to the 7, that's a really large number, okay, that's a number represented in scientific notation. Now, what this number, 9 times 10 to the negative 7, this is a very small number. So this number is large, right, because the exponent here is positive. This number is small because the exponent here is negative. And both of these numbers are written in scientific notation. Okay, so we are very familiar with the standard form, so we need to understand how we write a number from a standard form into scientific notation. So let's take an example, such as I'm going to do an example, and we're going to start doing some problems from the book. We're going to take this number, which is 3,297,000. This is a large number, right? We're going to write it in scientific notation. Okay? Scientific notation. Again, if I want to write it in scientific notation, I'm going to write it as a times 10 to the n, right? A has to be a number between 1 and 10, and n has to be an integer. Okay, so first I have to find my a. Okay, let me write my number here, because it's going to be very important that you understand what the process is. So the decimal point in this number is right now, right here. What I'm going to do is I'm going to try to get to a. A is a number between 1 and 10 by moving the decimal to the left. Now you have to keep track of how many spaces you're moving the decimal, because that number of spaces are going to be represented in your exponent, in the exponent that you give to the base 10. Okay, so let me just move. Here I go. 1, 2, 3, 4. Right now I'm not still between 1 and 10. 5, I'm 32.9. I'm not between 1 and 10. And now when I get here, now my decimal point gives me a number between 1 and 10. 3.297. So I have now my number 3.297, right? And now I'm going to have to read the exponent, okay? The exponent that corresponds to this n right here. Now this exponent is going to be positive, and it's going to be positive because this number is large. We're going to call large any number greater than 10. This number is extremely large. So let me count the spaces I just took to move my decimal point. So I have 1, 2, 3, 4, 5, and 6. Right? So now it's 3.297 times 10 to the 6. And that's the representation in scientific notation. Okay? Now let's take a small number, such as we're going to take in a small number. This is going to be my second example. Okay? We're going to take the number 0.000. Let me just give it 2 zeros. Okay? 547. I think I'm going to do a better job. I'm going to write this number again. Okay? So it's going to be 0.00547. This is much better. Okay? This number is a small number. Is less than 1, right? And it has to be represented in scientific notation. Remember, scientific notation again is 8 times 10 to the n. This number is going to have to be between 1 and 10. The decimal point now is here. I'm going to go to try to get to a number between 1 and 10. Okay, so here it goes, 1, 2, right? And 3. Now I have my decimal point right here. I have a number between 1 and 10. So that this is 5.47 times 10 to the. Now, let's remember that if I have a small number, this exponent is going to have to be negative. Okay? So I'm going to count the number of spaces, and whatever the number of spaces is going to be negative, whatever the number of spaces is. So let me count. I have 1, 2, and 3. So then now this is 10 to the negative 3. So the representation of this number is 5.47 times 10 to the negative 3. Let's go to page 188 and let's do some problems from the textbook. Again, I'm going to do the odd problems and you are going to do the even problems, always checking in the back of the book. So let me talk about problem number 75. Number 75, you have the number 65,200. And what I'm going to do is I'm going to convert this number from standard notation to scientific notation. Now remember the decimal point is right here. I'm going to move it, right? Now I have the number 6.52 and I'm going to multiply it times 10 times a power, and this power is going to be positive because this number right here is a large number. So we're going to count the spaces we have moved, okay? So the spaces are 1, 2, 3, and 4. So it's 6.52 times 10 to the 4th. Okay? Let's go and do problem number 77. And number 77, I have the light years in kilometers is 9,461. right? And then we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so this is really, and I think I'm going to rewrite this number because I really did not like the way the numbers came out. Okay, I'm sorry, let me just try it again. So it's 9,461, and then 1, 2, 3, 1, 2, 3, yes, 1, 2, 3, and 1, 2, 3. Okay, they are kilometers, and this is the distance light travels in 1 year. Okay, so let's represent this number, very, very large, in a standard form. So what you're going to do is you're going to make a great move, which is your decimal point is right here, and you're going to take it all the way to the right until you get right here. Yes, because right here is where I have my number between 1 and 10. So that would be 9.461. And then we had to count the number of moves. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So that's times 10 to the 15. And it's positive because this number is very, very large. Okay? Now, if we do problem number 79, now we have a very small number. That is the representation of 1 micron. So what we have is point, and then we have 1, 2, 3, 4. So we have 1, 2, 3, and 4. Yeah? 1, 2, 3, and 4. 39, 37 of an inch. Okay? Now, the decimal point is right here. I'm going to move it to the right, and I'm going to end up right here, the number between 1 and 10. So it will be 3.937 times 10. And because the number is small, it's going to be negative. So all I need to do is count the spaces. So 1, 2, 3, 4, and 5. So 10 to the negative 5. Okay? All right. Now the question is, how do I go from scientific notation into a standard notation? Okay, so the question is, how do I go from scientific notation to a standard notation? So let's just see an example of a number that is written in scientific notation and see what we do to move it to a standard notation. So let's take, for example, a number such as 7.08 times 10 to the third. This is definitely a large number because the exponent is positive and it's written in scientific notation, and we're going to write it in standard notation. So in standard notation, we won't have these exponents. Okay? So what I'm going to do is I'm going to multiply by 10 to the third. So when you multiply by a power of 10, if the exponent is positive, you're going to move to the right. So here it goes. In other words, you're going to move the decimal point to the right. So I'm going to move the decimal point from here. Yes, how many spaces? 3 spaces. Okay, so here it goes, 1, 2, and 3. Okay, now the decimal points right here. So 7,080 is the representation of this number. Okay, so if I have a number that is small, such as 1.4 times 10 to the negative 3, and I need to represent this number in standard form, again, I write my number, and now I'm going to move my decimal 3 spaces. But because the sign is negative, I'm going to move my spaces to the left. Okay? So it's going to be 3 spaces, so it's going to go 1, 2, and 3. Okay, so now it has been moved 3 spaces. 1, 2, and 3. So I'm going to complete with zeros, and the number is 0.0014. Okay, so this number right here, which is written in standard notation, can be written in this form right here. This is written scientific, this is going to be written in standard notation. Okay, so I would like to do in page 187, so you're going to have to trace back. I'm trying to cover this section a little bit out of order, but I think it just really makes more sense. So problem number 71, you have this particular number written in standard in scientific form, and you need to write it in standard notation. So again, I'm going to write it because the exponent is positive, right? This decimal point is going to be moved to the right. So here goes 1, 2, 3, and 4. So I'm going to complete with zeros, and the number will be 30,200. Okay? Easy. So let me go and do number 73. Remember, you're going to do the even numbers, and you're going to check in the back of the book. Okay? So I'm going to do 15.02 times 10 to the negative 7. The first thing that calls my attention is the negative number here in the exponent. Because the exponent is negative, I definitely know that this number is going to be small. Okay? And when I move my decimal point, I'm not going to move to the right like I moved right here. Yes, when it was positive, I'm going to move to the left. How many spaces? 7 spaces. So it's going to go 1 and 2, and then I'm going to have 1, 2, 3, 4, and 5, and one more. So it's going to be 1, 2, 3, 4, 5, 6, and 7. Okay? So the final number is 1, 2, 3, 4, 5, 1502. Okay? So again, this number was written in scientific notation and was moved to standard notation.